Hi, welcome back. So, ito yung first example natin ng previous video. So, kung merong questions regarding this example, you can just rewind yung previous video. Then, kung may question pa din, you can contact me dun sa GC natin para ma-address ko yung question nyo. Okay? Or sa LMS. Pwede kayo mag-message sa akin sa LMS. Okay. So, yung second example, let's start. So, yung procedure na ginawa natin dito will be the same dun sa second example natin. Ang kaibahan lang na is iba yung loading condition niya. So mangyayari, kung may hindi kayo masyadong naiintindihan kung bakit naging ganun yung step na kinuha ko, balik lang kayo dun or yung dun sa sunod-sunod na step na kino-consider natin sa solving ng mismong problem natin. Okay? So dito dun sa steps na to. Okay? So let's start sa second problem. Ito yung second problem natin. Okay? So the simply supported beam in the figure is loaded by a counterclockwise couple na C sub O at B. So ito daw yung loading niya. Okay? Pinapagawa sa atin is derive yung shear force and bending moment equations and draw the shear force and bending moment diagrams. Okay, again, neglect the weight of the beam, and for convenience, yung support reaction ng A and C have been already computed. Ang value daw ng A and C are both C sub O over L. Okay, so for this problem, wala tayong particular value ang gagamitin, so more on variable siya, pero madali lang naman yan. Okay, so dito ilang segment ang kailangan natin. Okay? So, siguro bonus na kasi may number dito. So, we need 2 segment kasi meron tayong A to B. Ito yung may load. Ito yung may load. So, 1 segment. Then, second segment is ito yung load. Ito yung another load. So, kaya naging meron ng 2 segment. Okay? The total length of the beam is L. And B is located 3/4 mula kay A. Okay? So, para i-solve, i-copy lang natin yung problem sa separate sheet. Okay. So we have a hinge the left side, then roller sa isang end. Okay, we have A, C, then si B may naka-act sa kanya na moment couple na C sub O. Okay. Then, yung distances natin. Distance ni B mula kay A is 3/4 ng L. Then, si C mula kay A is L, o yung total distance natin. Okay? Given ang value ni RA is downward, is equals to C sub O over L. Then, si RC is upward, na RC is equals to C sub O over L. Okay? Hanapin natin yung shear and moment expression for segment AB and BC. Then, yung ating diagram, shear and moment diagram. Okay? So, consider natin to na segment AB and segment BC. Okay? Let's start. So, segment AB. Okay. Pag segment AB, pinag-usapan natin, distances natin from 0 papunta kay 3/4 L na length. Okay. So, yung notation natin will be 0 less than equal x yung distance natin less than equal sa 3/4 ng L. Okay. So, later, magagamit natin yan. Mag-identify. So, ngayon kunin natin yung free body diagram. So, mag-create tayo ng cutting plane ulit, kada segment, di ba? Imaginary cutting plane. Okay? So, pagin natin yung A to B, matitira sa kanya, free body diagram natin. Ito yung A, and ito yung cutting plane natin. Okay? Then meron tayong RA na applied sa kanya na downward. C sub O over L. Then distance ng left support papunta kay cutting plane is X. Okay? Then yung positive sense na naka-apply sa atin, si V downward. Then si moment is lagging counterclockwise. Okay? Next is to get the shear and moment forces using equilibrium equation. So summation of forces. Vertical is equals to 0. Again, horizontal is neglected because walang horizontal force na applied dun sa given beam. Taking upward as positive. So, si RA is downward, so negative. RA minus V is equals to 0. So, para makuha si V, V is equals to negative RA, o V is equals to negative CO over L. So, ito yung value ni V. So, wala tayong magagawa. Kung negative siya, negative siya. Okay? Then, summation of moment is equals to 0, taking counterclockwise as positive. So, downward, as si RA is downward, pag nag-rotate siya, counterclockwise siya, so positive siya. So, RA, distance niya ay X, tapos si V is 0, tapos si moment, naka-counterclockwise din, so plus M is equals to 0. So, ang value ni moment is negative RAX or equals to negative COL times X. So, ito yung value ni moment. Okay? So, okay na yung segment AB. Next is yung segment BC. Okay? Segment BC. Which is applicable sa distance na 3/4 L less than equal X less than equal L. Yung pinaka-end natin. Okay? And draw lang natin yung free body diagram. Ito yung cutting plane. Then ito si B. So si B natin may applied na clockwise na C sub O. Okay? And si RA merong value na CO over L. Okay? Then yung distance nung leftmost dito is X. Tapos dito sa figure alam natin na itong from A to B ay ilan? Dito talaga yung distances nila. Okay, so 3/4 ng L. Then yung remaining natin dito will be yung total X minus 3/4 ng L. Pero hindi natin magagamit to kasi yung given natin ditong force ay moment na siya. So hindi na siya pwedeng mag-travel ng another distance. Pwede mo lang siyang papuntahin dun sa end na yan. So hindi na natin magagamit to, pero as a practice kung paano kunin yung distance na remaining, di mula dun sa total natin na distance na X minus lang natin dun sa na occupy nung A to B. Okay? Then shear na downward, then counterclockwise na moment. Okay? Okay, so kunin natin yung shear and moment forces. O summation of forces y is equals to 0, taking upward as positive. So RA, negative RA. Then si moment hindi pwede kasi kailangan natin ay concentrated lang. Si naka-akay BI moment, so hindi siya kasama sa shear. So yung kasama natin isa pa ay positive pala to. Plus B is equals to 0. So yung shear natin is equals to negative RA or V is equals to negative C sub O over L, which is the same as the first segment. Okay? Then summation of moment is equals to 0, taking counterclockwise as positive. So si RA magta-travel ng counterclockwise, so positive siya. Si CO, yung applied na CO is clockwise, so negative CO. Then si moment is counterclockwise, plus M is equals to 0. Kailangan natin value ni M. So M is equals to negative RAX plus C sub O, or M is equals to negative C sub O over L X, ito yung value ng RA, plus C sub O. So, pwede nating i-factor out yung C sub O. So, M is equals to negative C sub O, okay, times X over L minus 1. Okay, so ito yung value ni M. Okay, next is yung pag-draw na nung moment diagram natin. Okay, so again, i-extend lang natin yung loading points para ma-identify natin yung diagram natin para sa shear and moment. Okay, so let's start with shear. So from dito muna tayo, point A muna tayo. So A to B, ito yung gagamitin natin. So sa segment na to, ito. So since wala naman tayong arbitrary value ni X, so consistent lang na negative C sub O over L lang yung value natin. Okay, so mula dito may negative C sub O over L, tapos consistent lang tayo papunta sa B. Okay, dito tayo. Then pagpunta kay BC, pag substitute mo dito, consistent pa din siyang negative C sub O over L hanggang doon sa dulo. So ibig sabihin ito, i-extend mo lang papunta dito. C sub O over L. Then pagdating dito, sa support niya, meron tayong upward force na magko-close dun sa shearing force natin, shearing diagram natin. Okay, so ito na yung shear diagram natin. Okay, next is yung moment diagram. So sa moment, okay, since wala tayong value, try natin isulat by segment, no? Okay, so from dito, so segment AB tayo, ito yung gagawin natin. So segment AB. So sa moment to, okay, yung segment AB, moment natin is equals to negative C sub O over L times X. Okay, so kung at A, ang X natin is equals to 0, so ang moment natin will be, so any number multiplied by 0 ay 0. So ito yun, 0. Okay, so tapos at B, dito at B ang condition natin, so at B ang X natin na equal sa 3/4 ng L. Okay, so yung value ng moment will be negative C sub O over L times 3/4 ng L. Okay, so ito magka-cancel out. So ang value ng moment natin is negative 3/4 ng C sub O. So negative 3 sub C sub O. So negative, so assume lang natin ito yung value ng negative 3/4 C sub O. Okay, so ito, connect nyo lang. Okay, ito yung para sa segment AB. Ngayon, segment BC. Okay, kay segment BC, ang moment formula natin is negative C sub O times X over L minus 1. So kung at B, ang X natin ay 3/4 L, ang value ng moment is negative C sub O tapos times 3/4 ng L over L minus 1. Cancel out to. So M is equals to, so 3/4 minus 1 is negative 1/4. Negative 1/4 times negative CO is 1/4 C sub O. So meaning, pagdating dito sa next segment natin, 1/4 CO siya. So from negative 3/4 dito, kailangan umakyat tayo ng 1/4 CO. Okay? Then, para dun sa at C, ang x natin is equals to L. So, yung moment natin will be negative C sub O times L over L minus 1. So, ito magiging 1. So, 1 minus 1 is 0. So, CO times 0 is 0. So, ibig sabihin, magko-close na to dito. Which is correct. Dapat mag-close siya dun sa side na yan. Okay. So, this will be our shear diagram for the given problem. Okay. So, yun lang. So, yung pag-identify ng mga points dito, nakabase naman siya dun sa expressions natin. Then, kung i-analyze natin bakit nagkameron ng change ng direction ng moment dito, gawa yun ng presence ng couple natin. Okay? So, dun sa succeeding video natin, tuturo ko yung isang method kapag graphical method lang. So, hindi natin kailangan mag-solve ng ganito kahaba. Kailangan lang natin is yung reaction lang. Masasolve natin yun. No? So, kukuha natin itong diagram na to kung ito lang yung hinahanap na kahit hindi tayo dadaan dito sa very tedious na solution na to. So, pero for now, this is the method for solving yung shear and moment expressions natin. Kasi this is useful kapag halimbawa hindi dun sa directly kada loading point yung hinahanap yung value ng shear force. So, halimbawa, ang tanong sa inyo, hindi nire-require yung shear and moment diagram. Halimbawa, pinapahanap ano yung value ng shear at ng moment kapag ang distance natin from left ay halimbawa 0.5 L. So, substitute nyo lang yung value ng 0.5 L sa x. So, makukuha nyo yung value ng moment. Okay? So, that ends our session for this first online session. So, if you have question, so please message me dun sa GC. And for your activity, I'll be posting a set of problems, beam assignments, na will be submitted this week. Okay? So, see you guys again on the next video regarding shear and moment.